Right, in this video we're going to cover cracking and explain to you what it is and why also we need to do cracking. Okay, first thing, just to remind ourselves, there's a couple of differences between short chain and long chain hydrocarbons. Short chain, very useful because they're easy to ignite, easy to burn, therefore they're great for fuels. When they burn, they release their energy, and because of this there's a large demand for these types of hydrocarbons. Longer chain, not as useful, not a great demand because we can't use these as fuels, they don't burn as well. So the key difference between the demand of these is because these are better fuels, they have a low viscosity, that means they're very runny, therefore they can flow easily, and they're easy to ignite, which means we can burn them quite easily to release their energy. This table here hopefully shows us why we need to do cracking. Okay, so we've got two columns. We've got the supply, this is how many barrels we get from a sample of crude oil, and the demand is how many barrels we actually need to have from that sample. Petrol is the short chain hydrocarbon. This is the better fuel. Bitumen is a much longer chain hydrocarbon. This isn't a great fuel. This is used for things like tarmac and making of roads and weatherproofing. Look at the supply. We have 7,200 barrels of petrol being supplied from a sample, but the demand is far greater. So for a short chain hydrocarbon that's used as a fuel, the demand is greater than the supply, which means we're not meeting that demand that we need. Bitumen, the longer chain hydrocarbon, you can see here that the supply is far greater than the demand. So here we've got surplus, we have more than we need. So in the bitumen we have more than we need, in the petrol we don't have enough. So how can we make this work? Remembering this is a long chain hydrocarbon and this is a shorter chain hydrocarbon. How can we make these two things work for us? This is what we can do. If we take a long chain hydrocarbon, now I'm giving you one here as an example. If we just count these carbons up, I think I've put 10 in there. 1, 2, 3, 4, 5, 6, 7, 8. I've put 8 in there. So it's not very long, but it illustrates what we're going to do. So there's 8 of those in there. Remembering that H is 2 times that is 16, add the 2 is 18. So that's the hydrocarbon I've got here. This is containing all single carbon-carbon bonds. So this is saturated and it is a alkane because it's saturated, okay? And if we heat up this long hydrocarbon, then the heat will cause this to break down into a smaller hydrocarbon chain. For example, I've split this into one that's got 1, 2, 3, 4, 5, 6 carbons. So here we've got C6, and that will have 14 hydrogens if you count them up sitting in the molecule with the carbons, okay? So by heating this longer chain hydrocarbon up, we make a shorter chain. Remember, shorter chains, more useful as fuels, more demand. So if I take all the long ones that I've got a surplus extra, heat them up, I can make shorter ones, and then I can start to help meet the demands that this table showed me exist. You probably notice that as part of this process, I've actually not got enough carbons. So here I've got 8, and this side I've only got 6. So what I need here is 2 more carbons to make it become 8 and 8. So it follows the law of conservation of mass. I've got 18 hydrogens. I've only got 14 here. So I'm 4 short. This molecule, hopefully, you recognize as one of these molecules, which is unsaturated. This is an alkane. So when you do cracking, you produce a shorter, more useful alkane, but you also produce an alkene. Okay, so cracking leads to this shorter, more useful alkane and also an alkene. I've written a definition. It's underneath here. Let's have a quick look at it. So the definition for cracking is about breaking down a long chain saturated hydrocarbon into smaller, more useful saturated hydrocarbons, and we also make an unsaturated hydrocarbon as well. Breaking down, and we're using heat, remember, is called thermal decomposition. So thermal is because we need heat, decomposed is a decomposition, is breaking down. So we're breaking down long chain hydrocarbons into shorter, more useful ones. Remember, these saturated hydrocarbons are called alkanes. So you can see how we can start to flip in some of our words that are our key scientific vocabulary. And an unsaturated hydrocarbon is an alkene. So we make an alkene as well. Hope that makes sense. That's explaining what cracking is, why we need it, why does it have to work that way. Please watch the video. I'll just very quickly, I'm going to add on a very quick summary because it is a lot of information there. So the key things are this: short chain, big demand; long chain, not as in demand. Therefore, how do we make this table balance? How do we get more of the shorter chain, and how do we stop this longer chain being wasted? We don't want to do that. To do that, we take a long chain, we heat it up, it will break down into a shorter chain hydrocarbon that's more useful, and also produce an alkene, an unsaturated hydrocarbon as well.